All right, so we've been doing a whole bunch of stuff with circles, and we have been using central angles. Remember that a central angle is equal to the measure of the arc. On the other hand, an inscribed angle is not. An inscribed angle is an angle whose vertex lies on the circle and whose sides contain chords of the circle. So basically, if you draw two chords that have a common endpoint, you have drawn an inscribed angle. Okay, and it's actually pretty easy to understand that the prefix in, inside, to scribe is to make a mark or to write something. Okay, so you're drawing the angle inside of the circle, but it's not at the center, its vertex is on the circle. The intercepted arc is the 2 points that are on the chord and all the points on the circle in between there. So here I've got angle KHD as an inscribed angle. We say that arc KD is the intercepted arc. The other way that you will occasionally see this, not a ton, but occasionally, is we'll say that this arc subtends the angle. Okay, it has its endpoints on the angle. It's down here at the end. If we were to draw in segment KD, you don't need to worry about this, but if we were to draw in segment KD, we could say that segment KD subtends this angle also. It's what's at the end of the angle, if you want to think of it that way. All right. So it turns out the measure of an inscribed angle is half the measure of its intercepted arc. So here, angle KHD is half of the measure of arc KD. Unlike the central angle, what happens in a central angle? They're the same. And the way I think about it is it's like, well, this is twice as far away as the center is, because it's all the way on the far side of the circle. So yeah, it can't be the same size. It's got to be smaller. Real quickly, let me show you why that's true. Again, you do not need to copy any of this down, but I just want to show you real quickly why that's true. So if I've got a circle, and it works easiest if you have a diameter. So let's say the measure of this is x. And I was to go ahead and do this, and I want to know what's the measure of this. Okay, so the measure of this angle would be x, right? The central angle is equal to the measure of the arc. What's the measure of this angle going to be?
180 minus x.
Exactly right. Thank you, sir. 180 minus x. Then what kind of a triangle is this triangle right here? It's isosceles because these are both radii, right? That means that these two angles have to be congruent. So let's say I knew that this angle was 50. What would I do to find these two angles?
180 minus 50 divided by 2.
Okay, I take 180 minus this angle and then divide that by 2. So if I took 180 minus that angle and divided the result by 2, well, that'd be 180 minus 180 plus x when I distribute the negative sign over 2. It's x over 2. So it's half the measure of the intercepted arc. Okay? You can show it when it doesn't go through the center. It's just a lot harder to see. The explanation takes a lot longer. I think this is good enough. I think this is convincing. So let's use this idea to find the measure of arc ADE and the measure of angle DAE. I'm actually going to start with the angle first. Angle DAE is an inscribed angle because its vertex is on the circle. Its measure is going to be half of the arc that subtends the angle, or is intercepted by the angle. So this is just 78 divided by 2 is 39 degrees. And then the measure of arc ADE, let's do this in a different color. So arc ADE is this arc from A all the way around to D, all the way around here to E. That angle, or excuse me, that arc is intercepted by this angle. See how all of that arc is inside of the angle? So that means the angle was half of the arc. So the arc is twice the angle. It's 250 degrees. By the way, it just occurred to me, again, you don't need to write this, but another way that you could show that the angles are half the arcs, let's say we had a triangle, just any old triangle, inside this. I'm going to call these angles 1, 2, and 3. What do angles 1, 2, and 3 add up to? 180. Angle 1 intercepts this arc. Angle 2 intercepts this arc. Angle 3 intercepts this arc. What do those arcs add up to?
360.
And 180 is half of 360. You like that one better than the other one? Okay, so it's got to work out that way. All right. Another one here, notice that both angles D and G intercept what arc? They intercept arc EF. Do I know what its measure is? No. But since both of these angles intercept that same arc, and they're both inscribed angles, we know that 2x plus 3 is half the measure of arc EF, and that 7x minus 25 is half the measure of arc EF. If that's true, then what's true about these two things? They're equal to each other. So 2x plus 3 has to be equal to 7x minus 25. Add the 25 and subtract the 2x, and we get that 28 is equal to 5x. So x is 5.6. And they want the measure of angle EDF. That was 2x plus 3, so 2 times 5.6 plus 3. That's 10, 11.2 plus 3 is 14.2 degrees. In the very much not drawn to scale, that angle is a lot bigger than 14.2 degrees. Okay? Yes?
Why did you add the 3?
Because it wanted me to find this angle.
Oh.
Okay? All right. These next two theorems are actually corollaries to the first one. Because the first one is true, then these both have to be true. This first one comes up a lot. An inscribed angle is subtended by a semicircle if and only if the angle is a right angle. So Here, angle y is a right angle means that KAR is a semicircle, and if KAR is a semicircle, then angle y has to be 90. This is one of those cases where, since this angle is 180 degrees, this angle has to be 90. But you have to see that, right? It's not going to point out, hey, look, it's a semicircle, right? Anytime you have a diameter, look for semicircles and then look to see if you have any right angles. But they're not going to point out that this is a semicircle. Okay? And then the other corollary is that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. You're like, why would that be true? Well, let me show you. Again, you don't have to write this, but let's talk about angle J and angle M. Angle J does like this. What arc does it intercept? AME. And then let's go angle M. What arc does angle M intercept? AJE or just AE. What's true about those two arcs? They add up to 360. And each angle is half of the arc because it's an inscribed angle. So those two angles have to add up to 180. Okay, it's one of the things I like about geometry is everything fits together so nicely. All right, so let's find the measure of the angles in TLMD, this weird looking, not quite a trapezoid thing. Well, what we know is that the opposite angles are going to be supplementary. So angle T and angle M are going to be supplementary, and D and L are going to be supplementary. We'll start with D and L because we have an expression for their measures in terms of B. So 3B plus 25 plus 6B plus 20 has to be 180. Grouping the like terms, that's 9B plus 45 is 180. Subtracting, we have 9B is 135. Dividing, we get the B is 15. And I know that angle T and angle M are supplementary, so I'm going to find the measure of angle T. That's going to be 10 times 15 minus 69 is 150 minus 69 is what, 81? Yeah. So the measure of angle M is just 180 minus 81 is 99 degrees. So I've got that angle. Now notice it asked me for all of them, so I need to go back and substitute in. I found angle T. I've got that one. So I just need to substitute back in to find angle L and angle D. The measure of angle L will be 6 times 15 plus 20. That's 60 plus 30 is 90 plus 60 is 150. And if everything worked out right, angle D had better come out to be 30, right? So the measure of angle D is 3 times 15 plus 25. Uh-oh. That's not working. What did I do wrong?
Your angle L, it's supposed to be 6B plus 20 instead of 6B plus 60.
Oh, thank you. I was like, that's not even close to being right.
Should be 110.
So 110, thank you.
20.
So this is 120?
No. You're 30. It's supposed to be
Oh, I'll eventually write the right thing. So that's 110. Thank you. I appreciate the help. That's 45 plus 25 is 70. Okay, so it does work out. And that is a way you can check yourself. I didn't do it on purpose because I don't do that. I make enough mistakes without doing mistakes on purpose. But if you got down to the end and you're like, these two didn't add up to 180, you would know something went wrong someplace. It's a way that you can double check yourself. All right, any questions? Okay, your assignment is again in the book tonight, and just a quick reminder that you have a quiz on Thursday. It will not include inscribed angles, it's the stuff before that.